Hi everyone. In the last video I have shown you how to deal with matrices in Maxima software. I have also created a playlist of the videos I am making with the basic concepts of Maxima software. And this video I'm going to add to this playlist too. And today I'm going to show you how to solve algebraic equations in Maxima. So let's start defining an equation. We can define an equation like this. So Maxima knows that this is an equation because of the equal sign here. And for example, we can separate the left hand side and the right hand side of the equation. So the left hand side we can get with this command LHS, the right hand side with RHS. We can also solve equations, so let me show you a system of two linear equations. So the first equation is defined like this. The second equation is this. To solve this system, we can make this. And Maxima gives us the solutions. So LinSolve solves this linear system, and the first pair of entries here are the equations, and the second pair of entries are the variables in this case. If you have more than two equations, we can also solve, but here the first entry is going to receive, for example, 3 equations, and the second entry the 3 variables we want to find. We can also solve nonlinear equations. For example, let's just show this equation. And in this case, we have to use the command solve. And Maxima gives us the result. One interesting thing that Maxima does is also to put such expressions as in factors. And in this case, we can use the command factor. So this is another way to see that 5 is a solution of this equation and -1 is also a solution. We can also use the opposite command of factor, that is expand. So let me try to show you this expression. So this is the opposite of factor. We can solve more complicated equations. For example, let me try this equation that's a little more complicated. So if you have algebraic equations of high order, try to solve with this Maxima command solve. In this case, we have obtained a complex solutions. So it's interesting to show you that Maxima knows how to treat complex numbers, and this symbol %I here, it is the imaginary number. So this the square root of -1. We have seen in one of the previous videos that Maxima deals with constants by using this percent symbol and then a letter. So in this case we have the imaginary number. I'm going to show you that Maxima has also some commands to deal with complex numbers, since we have got a complex solution here. For example, let me put these solutions in a list. So we can see that when Maxima solves an equation, it puts the solutions in a list. And for example, if I want to select the first solution, I can make this. So this is how we get specific elements of a list. We have seen this in the video where I talk about lists. I will let the card here. And for example, I want to define this right hand side of this equation as a variable of Maxima. Then I can make this right hand side. Then my variable has this value, actually a complex number. So I want to select the real part of this solution. Then I can make this. I want to select the imaginary part. Then I can make this. If I want to compute the absolute value of this number, then I have this. So this is just an example of things that Maxima does with complex numbers. I will not talk much about this because we don't use much this to make the animations we are going to make here. But if for more complex animation, maybe you need to know how to deal with complex numbers. Let's try now an example of a motion with a constant acceleration, to see how solve can help us to solve physics problems, or maybe to prepare our classes, for example. So let's try a particle that starts on this position. It has this initial velocity and it has its deceleration, and the motion equation is going to be this. Then we want first to find the instants that when the particles pass by the origin of the system. So we can make this. Then we have these results. Let's also try to determine when the particle changes its direction. So in this case, you have to know the velocity. So the equation to the velocity of the particle is this. Then we can find the returning instant. We can find by doing this. If you want to determine where it changed its motion direction, then we have to put this time in the position function. So let's make this. We are going to select this solution. In this case, I'm going to say that the return time was the right hand side of this output. That is the last output. But this output is a variable, so we can make this. So remember that this percent sign, it refers to the last Maxima output. We have also made a video about this. I'm going to give the card here, so it's interesting to know what this means. And now that we have the return time, we can find the return position by simply doing this. And the return position of the particle was this. So I hope I have convinced you that solving algebraic equations with Maxima can be interesting. For example, if you want to prepare a test for your students and if you want to change the initial parameters, for example, initial position, initial velocity, and to know if the time is going to be difficult or not to the students to find, then you can change in Maxima and simply see the result. You don't need to solve the problem by hand every time. So I hope you have liked the video today, and see you in the next video.